Hello, welcome to the playlist of videos on essential statistics for data science. I am Hemakumar Kasala, and in this playlist of videos, I will explain you in detail everything about hypothesis testing. This playlist is split into 5 lectures, namely concepts, null and alternative hypothesis, hypothesis testing, type 1 and type 2 errors, applying the concepts, hypothesis testing illustration with examples, and power of the test and evaluation of beta, which is nothing but the probability of type 2 errors. In this video, we will focus on the first lecture, namely concepts, null and alternative hypothesis. Let's get into the video. In two of the previous two lectures, point estimate and confidence interval part 1 and point estimate and confidence interval part 2, we learned to estimate a population characteristic and with a chosen degree of confidence level to estimate the confidence interval using a point estimate, in other words a sample statistic, from a sample drawn out of that population. Is it possible to verify or decide on a claim, in other words a hypothesis, involving a value of a population characteristic using a point estimate, in other words a sample statistic? For example, a manufacturer claims that the lifetime of light bulbs belonging to their brand and of certain wattage is 1000 hours. Is the population mean mu of the lifetime of the light bulbs less than the claim, that is 1000 hours? Is mu less than 1000? Can a test be conducted on a sample of those light bulbs and a decision on that claim be made? Let's explore. Hypothesis is a claim or a statement about a value of a population characteristic or values of a set of characteristics. For example, if we make a broccoli delivery service, we will have at least 40% subscription rate among vegetarians in San Francisco. This is an hypothesis, or in other words a claim. The population characteristic in this case is the population proportion of success pi, which equals number of subscribers divided by number of vegetarians in SF multiplied by 100. The claim or the hypothesis is population characteristic pi equals 40%. More examples on hypothesis or claims. Mu equals 1000 is the claim where mu is the mean number of characters, that is the population mean in an email message. Pi is less than 0.01 is another claim where pi, the population proportion of success, is the percentage of emails bounced. Remember, hypothesis is a claim on a population characteristic like population mean mu, population proportion of success pi, etc. Not on a sample statistic like sample mean x bar or sample proportion of success p. Hypothesis test is a procedure that uses a sample data to decide between one among two competing hypotheses. For example, between the hypothesis mu equals 500 and the competing hypothesis mu not equals 500. And similarly, the hypothesis pi equals 0.4 and the competing hypothesis pi is less than 0.4. Note, if it was possible to verify using the entire population data, hypothesis testing would not be required. Since a census exercise like this is not always possible, a hypothesis test using a sample is deployed. In the following two example hypothesis statements, mu equals 500 and mu not equals 500 and pi equals 0.4 and pi is less than 0.4, there is an initial assumption in each case, which is mu equals 500 and pi equals 0.4, and there is a competing claim, an alternative claim, which is mu not equals 500 and pi is less than 0.4. The values in the initial assumptions 500 and 0.4 for mu and pi respectively are called as the hypothesized values. Initial assumption mu equals 500 denoted by H0 colon mu equals 500 is called as the null hypothesis, which is the claim about the population characteristic that is initially assumed to be true. The alternative claim mu not equals 500 is denoted by HA colon mu not equals 500 is called as the alternative hypothesis, which is the competing claim contesting the null hypothesis. Similarly, H0 colon pi equals 0.4 and HA colon pi less than 0.4 are the hypothesis statements concerning the population proportion of success pi. Hypothesis test is carried out to decide between H0 and HA. H0 is rejected in favor of HA if and only if there is a strong evidence in the sample data that suggests H0 is false. Else, H0 is not rejected. Therefore, the results of the hypothesis test is either reject H0 or fail to reject H0. While the null hypothesis in a hypothesis test takes the following form: H0 colon population characteristic equals hypothesized value, the alternative hypothesis takes one of the following three forms: HA colon population characteristic is less than hypothesized value, HA colon population characteristic is greater than hypothesized value, or HA colon population characteristic not equals hypothesized value. Notice the difference: equal to in null hypothesis versus less than, greater than, or not equal to in alternative hypothesis. Depending on the context of the problem, the alternative hypothesis sets the intent of the hypothesis test that verifies statistically if the population characteristic as estimated from the sample is lower than the hypothesized value, that is less than, or is higher than the hypothesized value, that is greater than, or not the same as the hypothesized value, that is not equal to, either lower or higher than the hypothesized value in this case. Let's understand with a few examples. Assume mu denote the true mean diameter of the tennis balls produced by a particular machine in a factory. The machine was initially calibrated to produce balls with a true mean diameter mu which equals 3 inches. Over a period of time, the manufacturer was concerned that the balls do not adhere to the desired specification anymore. Hypothesis test is to be carried out to decide if there is any deviation from mu equals 3 inches in order to put corrective measures in place. The appropriate null and alternative hypothesis in this case would be H0 colon mu equals 3 and HA colon mu not equals 3. Since any deviation from mu equals 3 inches, either larger than 3 inches or smaller than 3 inches, is not tolerated, the correct alternative hypothesis in this case is HA colon mu not equals 3. Let's take the lifetime of light bulbs example. The manufacturer of certain brand claims that mean lifetime of light bulbs mu equals 1000 hours. Does the product meet the claim mu equals 1000 hours? Mean lifetime of the light bulbs mu can be greater than 1000 hours but should not be less than 1000 hours because they will lose customer trust. Hypothesis test is to be carried out to check if there is significant evidence to decide mu is less than 1000 hours. The appropriate null and alternative hypothesis in this case would be H0 colon mu equals 1000 and HA colon mu is less than 1000. Since a value of mu greater than 1000 hours is not seen as a concern, while mu less than 1000 hours is indeed, the correct alternative hypothesis in this case is HA colon mu is less than 1000. Note, the hypothesis H0 colon mu equals 1000 and HA colon mu is less than 1000 is equivalent to stating H0 colon mu is greater than or equal to 1000 and HA colon mu is less than 1000. When H0 is rejected in favor of HA, the mean lifetime value mu as observed from the sample is less than 1000. It doesn't matter whether the null hypothesis states that mu equals 1000 or mu is greater than or equal to 1000. In either of these cases, the H0 is rejected. Therefore, it is adequate and also customary to state a single hypothesized value in the null hypothesis, as in H0 colon mu equals 1000. Let's take another example. The currently deployed standard treatment for tumor is considered reasonable cost-wise and low as far as the side effects are concerned. With the current setup, the population proportion of success, that is success rate pi, equals 0.85. The research team is tasked with evaluation of a newer treatment and decide if the current standard treatment should be replaced with a newer one. The driving factor in the evaluation could be to decide if the newer treatment delivers higher success rate compared to the current one, given that the cost and the side effects with the newer treatment are not considered as issues. The appropriate null and alternative hypothesis in this case would be H0 colon pi equals 0.85 and HA colon pi is greater than 0.85. Since we require compelling evidence that pi is greater than 0.85 in order to reject the null hypothesis, the correct alternative hypothesis, as rightly chosen in this case, is HA colon pi is greater than 0.85. Suppose we consider the population proportion of success, that is the success rate pi equals 0.3 with the current setup, instead of pi equals 0.85 as in the previous case. And research team is tasked with evaluation of a newer treatment to decide if the current standard treatment should be replaced with the newer one. The driving factor in the evaluation in this case could be to decide if the newer treatment does not worsen the success rate further, as the motivation behind the evaluation could be some cost benefits and or lesser side effects with the newer treatment. The appropriate null and alternative hypothesis in this case would be H0 colon pi equals 0.3 and HA colon pi is less than 0.3. The newer treatment should not be considered if H0 is rejected favoring HA. If there is no compelling evidence to reject H0, the newer treatment could be considered to replace the older one, not because the success rate of the newer treatment is better than the current treatment, rather because the cost and or the side effects with the newer treatment is motivating to replace the current one with the newer treatment. We discussed three different examples to understand on how to choose among the not equal to, less than or greater than inequalities in the alternative hypothesis, and also discussed why we use just equal to in the null hypothesis instead of less than or equal to or greater than or equal to. We discussed on the possibility of verifying a claim on a population characteristic using a point estimate, null, that is the claim, and alternative, that is the competing or counterclaim hypothesis, introduction to hypothesis test, how to frame null and alternate hypothesis, and a few examples to understand the framing of null and alternative hypothesis. That brings us to the end of the lecture on concepts, null and alternative hypothesis. See you back soon with the second lecture on hypothesis testing, type 1 and type 2 errors.